Hey guys, so lesson 2 for this unit, we're looking at filling up a classroom with tennis balls. So this is again estimating size. So obviously in real life, you're probably not going to fill up a room with tennis balls. You may play like a prank on someone and do tennis balls, or like sometimes there's balloons, fill up a balloon. So you could say, okay, well, based off of the room size, how many balloons will I need if they're approximately this size? So you may use this one, but as we go, like I said, they'll get to where they're somewhat specific. We have some formulas, and they're up here on the screen and on your sheet when you put it in the Google Doc or if you copy it down. So what you're going to want to utilize are the ones listed off here. So let's see, let's change our color. There we go. So we've got right here. So find the circumference of a circle with a radius of 5 inches. We're looking for our circumference, which is our C. We have 2 pi r. So when we say 2 pi r, that's where this becomes important because the radius equals 5. So we now would put in 5. All right, which essentially is 10 pi, which is going to be pi 3.1415. So we would multiply that by 10, so we have 31.42 inches. All right, so that's the circle with a radius of 5 inches. So we're basically, we cut this this tennis ball. It's not quite 5 inches, but it's just giving us an example. Find the area of a circle. So still, we're flat right here. We don't have a sphere yet. So we're finding the area of a circle with a radius of 4 centimeters squared. So area, what we're looking to get, is pi, and this one's r squared. So 4 squared, which is 16. So you could call it 16 pi, which is going to equal 50.27 centimeters squared. All right, so that tells us if we took the slice, and we're not just trying to find all the way around, we're trying to find everything on the inside. That's our area of our circle. Then we're trying to find the volume. All right, so we've got our volume is 4/3 pi r cubed, and we know that the radius is going to be 3 inches for this sample. So the volume 4/3 pi, and then radius is 3, so we're 3 cubed, which is 27. You can just put all that in the calculator, and it's going to give you 113.1 inches cubed, and that's, we're just adding on. All right, so taking that, we're going to assume that all the furniture has been taken out of the classroom, and we're saying how many tennis balls would be needed to fill up the entire classroom that you see an empty classroom behind me. So right here, you see all this space. It's all empty, but we took all the furniture out. How would we be able to identify like filling all of this out? All right, so answer each question in complete sentences as you work your way through. So if we know the tennis ball has a radius of 1.25 inches, so now we have the correct radius that we need, not just the sample problems that we're looking at. If we stack them on end to end, about how many will fit in a 1 by 1 by 1 cube? So if we're saying a 1 by 1 by 1 cube, then what we're taking there is we're taking volume of that, and we're going to say, all right, well, I know my radius is 1.25 inches. A diameter, that's 2 times your radius. So if we want to know, okay, well, we want it all the way across, then we'd have to double it, so 2.5. And then if we are taking our 1 by 1 by 1, we know 1 by 1 by 1, if we multiply that, it's just 1, but we want to know, okay, this is inches. So our conversion from the last one we saw was 1 foot is 12 inches. So if we do 12 inches times 12 inches times 12 inches, that's then different, because now that is going to give us 1,728 inches cubed. All right, so we're dealing with our cubed because we have length, width, and height in a room, or in a cube in this case. All right, so from there, we know if we want to use our conversion, so we're saying that we have 12 inches is one part of this, and we know that we have 2.5 inches all the way across. If you cut the tennis ball in half so you could measure from one side to the other, we're saying 2.5 inches. So we divide that, that gives us 4.8 tennis balls that could fit in there. But again, much like people, we don't want to know how many partial tennis balls can be fit in, we want to know how many full. So we're going to have to say, okay, well, only 4 tennis balls fit in our 1 by 1 by 1. So then, when we go from there, we're saying, all right, well, if we are looking to see with the size room, and the example given was just a 1 foot by 1 foot, but let's say if it was like, maybe 4. So if we did 4 tennis balls for each of these, all right? So 4 by 4 by 4 tells us 4 times 4 is 16, 16 times 4 is 64 tennis balls could potentially fit in that 1 foot by 1 foot by 1 foot cube. So now let's get to the bigger picture. All right, so that's kind of the smaller picture. If you think like if any of you play tennis and you see like them picking up with the big tennis ball, so it's about 1 by 1 by 1, or 12 inches by 12 inches. Given a classroom, we're saying the average, let's say that it's a 10 feet by 12 feet by 8 feet, which is not a huge classroom, but for the sake of this, we'll use that. All right, so assume all furniture has been removed. We're gonna go through the same process. So instead of saying 10 feet, we want to know inches, and we're still going to use the same radius that we used above to be able to work with. So let's call it, instead of 10 feet, it's 10 times 12, so 120 feet. 12 times 12 is going to give us 144, inches, I wrote feet. 120 inches times 144 inches times 8 times 12, which 8 times 12 is going to give us 96, times 96 inches. All right, so that's the dimensions that we're working with. If we would take that and multiply all of that out, that's going to kind of give us the general, the room size, but let's just go with each individual one. All right, so 120 inches, and we know we're saying 2.5 is the diameter of the tennis ball. So when we divide that, that's 48. All right, so we know 48 tennis balls if we just kind of put them all along the one stretch of wall that's going to be 12 feet. All right, if we are looking, 10 feet. And then if we're looking at the stretch of wall that's 12 feet, then we're going to say 144 divided by 2.5, because again, that's our diameter. So that's 57.6. And then when we're looking at the last part, the 8-foot segment, we take our 96 and divide it by 2.5, and that's going to give us 38.4 tennis balls. All right, so again, we can't have a partial tennis ball when we're trying to figure this out. So what we have here is 48 by 57, because we can't take the partial, and then 38. So 48 times 57 times 38. Let's put that all in the calculator. We put it all in, and we get 103,968 tennis balls. Will fit in that classroom. All right, then the question is, all right, well, if we stack the tennis balls interlocking, how would this affect our overall estimate? And when we look at that, well, if we were able to stack them, then what that would do is it would have less empty space because they would be like more interlocked, and that means, for sure we'd be able to add more. So you could just say that it would increase our estimate overall. All right, guys, so that's our second lesson. Like I said, you'll have the ability to put this on Google Doc and then turn it in if need be. And if you have questions, I'm always here to help. All right, guys.